Hey everyone, in this video we'll learn how to solve any quadratic equation by completing the square. Completing the square works for any quadratic equation out there, no matter what the terms are, no matter what a equals, whether it's 1 or not, and it works all the time. Unlike factoring to solve a quadratic equation, it may not always be easy to factor the equation to then solve for x, but completing the square works every time with any quadratic equation. So let's learn how to do it. So let's say we had this equation right here, 4x squared equals 20x minus 41. So the very first step is we want to get this in our ax squared plus bx plus c equals 0 form. We want to get it in that standard quadratic equation form as our first step. So let's go ahead and do that. And first let's write down ax squared plus bx plus c equals 0. Good. And as you can see, our ax squared term is right here. And on the other side of the equal sign, we have bx and c as well. So what we can do, let's just rewrite this down here, 4x squared. So let's write this quickly, 4x squared equals 20x minus 41. Let's move the bx to the other side. So let's move the bx to the other side of the equal sign. And we'll do the same thing with the negative 41 as well. So one at a time. Positive 20x, what's the opposite of that? Negative 20x to both sides. Good. And then we are left with 4x squared minus 20, so apologies, 20x, so minus 20x equals, this got canceled out, so we are left with negative 41. And we are also going to move the negative 41 to the other side as well. So let's go ahead, add 41 to both sides. So opposite of negative 41, going to add 41 to both sides. 41 here and 41 there. And we are left with 4x squared minus 20x plus 41 equals 0. Excellent. So that's our first step. And let's make sure we know what our a, b, and c are. So our ax squared term is here. Our bx term is here. And our c term is there. So let's write it down. Our a equals, so you could see our a is 4. And our b, as you could see here, is negative 20. And our c right here is positive 41. So c is 41. Great, so that's our first step. We have it in the form that we want it to be. And our second step is we are going to divide both sides by a. So let's just rewrite this. We are going to divide both sides by our a term. And what did we say a was? A was 4. So let's divide both sides by 4. So on the left side of this equal sign, dividing this quadratic by 4, it's the same as dividing each term by 4. So let's go ahead and do it term by term. What is 4x squared divided by 4? Well, what's 4 divided by 4? Just looking at the coefficients, it's 1. And then we're just left with the x squared because the 4 and the 4 cancel out. The 4 and the 4 would just cancel out. We are just left with x squared, which is this part right here. Good. Now, this piece, negative 20x divided by 4. Well, what's negative 20 divided by 4? That is negative 5. So negative 5 and then carry the x. Perfect. And what's positive 41 over 4? We can just simply leave that as a fraction. 41 over 4. It doesn't simplify any further, so we could leave it like that. And then the other side right here, what is 0 divided by 4? That is simply just 0. 0 divided by almost anything is just 0. Good. So that is our second step. We've divided both sides by a, by 4. And then our third step is we are going to move the new c term right here. So let's actually write the new a, b, and c terms. So our a is our new a. There's no coefficient in front of it, so that's just 1. And what is our new b? Our new b is -5. And what is our new c? Our new c is 41/4. Good. So our next step is we are going to move our c term to the other side of the equal sign. And how we're going to do that, let's actually just rewrite this. X squared minus 5x plus 41/4 equals 0. So what's the opposite of positive 41/4? That is minus 41/4. So minus 41/4 to both sides. That will cancel these out. And we are left with x squared minus 5x. And I'm going to leave some space here, and you'll see why in a second. Equals, and what's 0 minus 41/4? That's simply just minus 41/4. Good. So that's our third step. We've moved our c term to the other side of the equal sign. And what is our fourth step? So our fourth step is very important. We are going to add both sides by b/2 squared. b/2 squared. And what that means is we're going to take our b term. So what did we say our b was? Our b is -5. So we'll take our -5. So -5 right here. We're going to divide it by 2. So -5/2, we can just leave that as a fraction. And then we are going to square it. So we take our b, we divide it by 2, and we square it. So what's -5/2 squared? Well, let's square the numerator and denominator. So what's -5 squared? That is positive 25. And the denominator, what is 2 squared? That is 4. So we're going to add both sides by by 25/4. So we'll add 25/4 and just erase some of this. Let me put that back. We're going to add 25/4 to both sides. Good. So we did that, and we can actually go ahead and combine these fractions. So -41/4 plus 25/4, we can add these fractions. And it's easier because we have the same denominator. They're both 4. So let's add the numerators up. What's -41 plus 25? That is -16. So -16. And then we'll carry over the denominator over 4. Perfect. Equals, and then we'll write the rest of this down. X squared minus 5x plus 25/4. So what is our fifth step? We're at this point now. This is where our quadratic looks like. What do we do next? So what we have done by adding b/2 squared to both sides, what that does is that guarantees that this trinomial right here, this is now a perfect square trinomial. And that's partly why it's called completing the square, because we have created a perfect square trinomial right here. This is guaranteed to be a perfect square trinomial. And that means we can write this as a binomial, so x plus some number squared. And then equals -16/4. Now, what number are we going to add here? We are going to add b/2. So b/2. And again, what is our b in this case? Our b is -5. So we're going to add -5/2. And x plus negative 5 over 2, that's the same thing as writing x minus 5 over 2. Plus minus is simply just a minus. So x minus 5 over 2 squared equals negative 16 over 4. Excellent. What is our next step? So what is our step 6? We are going to take the square root of both sides, because ultimately our goal is to solve for x, and this square is getting in the way. So we are going to remove that square by taking the square root of both sides. So that will cancel that out, and we are left with x minus 5 over 2 equals, and this is very important, in any equation at all, when you're taking the square root of both sides, you always have to have the plus minus symbol there, and I'll explain why. So plus minus the square root of negative 16 over 4. So just write that again, the square root of negative 16 over 4. This plus minus symbol right here is very important, this plus minus symbol in green. And let me show you a quick mini example just separate from this on why it's important. Let's say we had x squared equals 16, and we were told to solve for x. You could probably guess right away that x is 4, right? X is 4, because you know 4 squared is 16, because you know 4 squared is 16. And that's true, and x can also equal negative 4. And that's because negative 4 squared is also positive 16. Squaring a negative will still give you a positive number. So when you solve this mini equation right here, and you go ahead and try to take the square root of both sides to isolate the x, so that square root will cancel out the x, or the squared. We are left with x equals. You have to put that plus minus symbol there, and then the radical 16. And now what is radical 16? That is 4. So 4. So x equals plus minus 4. And what that translates to is x equals positive 4, which I'll just write as 4, and x equals negative 4. Those are the two solutions to x. X can equal positive 4, and x can equal negative 4. So that's why the plus minus symbol is very important. And you always add the plus minus symbol when you're taking the square root of both sides in any equation. So this is where we are now. X minus 5 over 2 equals plus minus negative 16 over 4. That's where we are. And again, our goal is to isolate x. So how do we finally get to x? We are going to get rid of this negative 5 over 2 by adding 5 over 2 to both sides. So add 5 over 2, add 5 over 2. And finally, we have x equals, so I'll write 5 over 2 first. So 5 over 2 plus minus negative 16 over 4. Good. And let's actually evaluate this radical negative 16 over 4. So according to the law of radicals with fractions, this radical negative 16 over 4, I'll just write it up over here. This is the same as radical negative 16 over radical 4. So we know what radical 16 is. On the numerator, that's 4. But radical negative 16, we've already learned about the imaginary numbers. That is 4i. So radical negative 16 is 4i. And then over radical 4, so in the denominator, radical 4 is simply just 2. And we can simplify this further. What's 4i over 2? What's 4 over 2? That's 2. And then carry over the I, so 2i. So ultimately, this blue right here, we could just replace it with 2i. This evaluates to 2i. So let's go ahead and write that. So as you can see, our answer is actually complex. It's a complex number. It's no longer a real number, our x that we found. And we are left with this. X equals 5 over 2 plus minus 2i, and we can actually split this up into two solutions. So what this plus minus symbol does is it means x equals 5 over 2 plus 2i, and it also means x equals 5 over 2 minus 2i. Those are the solutions to x. So x equals 5 over 2 plus 2i, x equals 5 over 2 minus 2i, or you could simply go ahead and leave it in this form. Again, this plus minus symbol in this case, it means it could either be positive or negative 2i, plus or minus 2i. That indicates that x has two solutions. And those are our two solutions. And that's how we use completing the square to solve for x in a quadratic equation. And again, it works for any quadratic equation out there. All you have to do is follow the steps, and you can solve for x for any quadratic. I hope this video helps, and if you have any questions, please leave them down in the comments below, and thank you for watching.